Woohoo, we're live. This is Math 60 Intermediate Algebra, and we're in 7.3, which is simplifying and combining radical expressions. And what I want to say is I'm hoping that you've just watched the bare math video. I have a video that's just about bare math, and you should watch it because it explains what I'm about to talk about. You're welcome to not, and then just be very confused. But I'm not going to explain this completely. We're going to be talking about the bare math. Oh no, the bears. Yum, 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 yum. Okay, so the light review is you don't have to be faster than the bear. You just have to be faster than your friend. And so what we're going to do is, in order to simplify radicals, this is a radical, we are going to go ahead and break this down, see who's inside of here. So I'm going to break it down. I'm going to say, oh, this is 32 times 100. 100 is 10 times 10, which is 5 times 2, 5 times 2. 32 is 2 times 16. You could also do like 4 times 8. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Oh my gosh, we've got a lot of 2's running around. So inside our radical, in the radicand, hate that word, I've got 2 5's, and I've got 1, 2, 3, 4, 5, 6, 7 2's. Oh, I almost made it. There we go. Okay, sorry, I made it a little too short. So this is our cabin in the woods. And again, the Wi-Fi has just gone out, and so everyone is like, oh no, we need to escape. But there's a bear outside. And the problem is if you just run out of the cabin, the bear will eat you. So what we're going to do is we're going to go in pairs. So the 5's will run together. They look identical. And this way, the bear is just going to eat one of them. So one of them will get away. Okay, the 5's go running. And then the bear comes, yum, 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 and eats one of them. And only one makes it out. Now, seriously, if you've not watched the bare math video, this is going to seem really bizarre. It is possible that if you watch the bare math video, it's still bizarre, but hopefully less confusing. So then the 2's go running. And again, you have to go running in pairs. Why is it pairs? Because it's a square root. So 2 go running. The bear comes. Yum, 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 yum. Okay, 1 makes it out. This pair of 2's goes running. Yum, 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 yum. 1 makes it out. This pair of 2's goes running. 1, 2 makes it out. Yum, yum, yum. But then we have a single 2 left. It does not have any friends to run with. It's okay. It's just a number. You won't feel sad. But what we do is we say, you stay in there and we will send for help. And we won't actually send for help. The 2 will be there forever, but that's okay. Trust me, it's okay. It's a number. They really don't have the feelings like you think they do. I mean, that we know of. 5 times 2 times 2 times 2 is 40. And this is how we get from 3,200 inside of a square root or inside of a radical to just 2 inside of a radical. And this is considered simplified. Why? Well, basically, radicals are really hard to work with. They just behave in the weirdest ways. And so to simplify things, what we need to do is we need to get as much out of the radical as we possibly can. So anything that is a perfect square needs to come out of a radical. That's the rule. And so bare math is one way to do it. If you already know how to simplify this and your teachers did not use a bear, first off, I feel sorry because it's way too fun. But also, please use whatever method you already know. This is just a method for folks who are getting this for the first time and they're like, oh my gosh, what's even happening? Okay, so let us move on. Now, in the video, I showed you how to do square bears. So this is a square bear because square root means square bear. Okay, Square root is square bear. So two people run at a time. There we go. Okay. Bigger bears. Now, I only have one bear puppet. I should have a bigger bear. I don't. Just imagine it's bigger. I'll put it closer to the screen so it's bigger. Much bigger bear. Okay, so this is a cube bear. A cube bear means 3 people run. Okay, so I've got the cube root of 27. I do exactly what I would do before. I'm going to break it down 3 times 9, 3 times 3. Okay, cube root. And so I'm going to write 3 times 3 times 3. So I have my prime factorization there. I've broken it down. I know who's there. And it's a cube. So 3 people run. So all 3 threes run. Ah! And then what happens? Much bigger cube bear comes by and eats them all. No, almost all. How many make it out? Just 1. The cube root of 27 is 3, which we know. 3 cubed is 27. Yep. Okay, shall we do another one? Woohoo! This one is the cube root of x to the 6th, which is nice because it's kind of already factored for us. X times x times x times x times x times x. 1, 2, 3, 4, 5, 6. Yes. You do not have to write the multiplication in between. I'm just emphasizing. So it's a cube bear. So 3 x's go running. Yum, 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 yum. 1 makes it out. These 3 x's go running. Yum, 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 yum. 1 makes it out. We end up with x squared. Now, do we have to use this? No, we don't have to use this. Cube root of x to the 6th is x to the 3, x to the 6, 6 over 3. What is 6 divided by 3? 6 over 3 equals 2. So we didn't have to go through the cube bear if we didn't want to. We could have just used the rational exponents here to get x squared. Same answer. Woohoo. Okay, let's go looking for the 4th root of 16. So this is a 4 bear. Okay, 16 is 4 times 4. Each of those is 2 times 2. It's the 4th root of 2 times 2 times 2 times 2. Remember that if you're going to do a bear math, that's how many go running, and they have to be identical. So I want to look for 4 things that are identical. Oh, these are identical. All 4 go running. And this is even bigger bear. Yum, 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 yum. Only 1 makes it out. Oh, I didn't put my square around this. Shall we check? 2 to the 4th power is 16. Yay! So the 4th root of 16 is 2. Okay, let's try the next one. Pardon me. The 5th root of x to the 12th. Okay, so we're going to need a 5 bear, right? And I need to write 12 x's. 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. They're all multiplied together. Times, 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 times. This is like that game. What is it called? Nimbly Peg? Mumbly Peg. Anyway. Sorry. So it's a 5 bear. So 5 identical people have to go running at the same time. 1, 2, 3, 4, 5. They go running. How many make it out? Yum, 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 yum. 1 makes it out. These 5 go running. Ah! Nom, 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 nom. Okay, there are only 2 left. They don't have friends to go running with, so they're stuck inside the cabin. So we end up with x squared times the 5th root of x squared. Be really careful that these 2 get separated a little bit, because otherwise it'll look like the 25th root or something. Okay, so let us also note the 5th root of x to the 12th is x to the 12 over 5, right? 12 over 5 is equal to 2 and 2/5. That means it's x squared and the 5th root of x squared. So we could do it with rational exponents as well. So you can work either with a 5 bear, do all your running, or you could just do it numerically like that. Woohoo? Woohoo. Okay, next up, we're going to add and subtract radicals. Everyone's going to love this. It's going to be so much fun. Not.